Students, last class we have discussed the discovery of the proton, Mulligan ion drop experiment and charge to mass ratio. So now you can see that discovery of the neutron. After the electron, next discovery is proton. After the discovery of the neutron. Neutron doesn't have any charge, neutral charge. That's why discovery of the neutron has taken some time. So who discovered the neutron? What is the charge to mass ratio? What is its mass in grams? What is its mass in AMU? Now we can see. So in 1932, James Chadwick, the scientist name of the discovery of the neutron is James Chadwick, bombarded a thin sheet of beryllium by fast moving with the alpha particle. As a result, observed that certain neutral particle, that means charge is 0, is emerging out this particle named it as a neutron. So he has taken the beryllium thin sheet he has taken, which is having the mass 9 with the bombardment with the alpha particle He plus 2, which is having the mass is 4. It is having the mass is 4. So whenever he allowed the alpha particle through the beryllium is bombarded with the alpha particle, he observed that one particle, subatomic particle he observed, which having the mass is 1 and charge is 0. So neutral charge particle he observed. So now you can see that is having the mass is 1 but charge is 0 charge. So neutron doesn't have the any charge, that's why it is not deflected in the electrical and magnetic field, it not deflected. So now you can see that mass of the neutron in a grams, mass of the neutron in grams 1.675 into 10 to the power of minus 24 grams. Mass of the neutron is slightly greater than the mass of the proton. Otherwise, you can say that approximately equal. But mass of the neutron approximately here greater than the mass of the electron. So mass of the neutron we got in a grams. So how we will take in a AMU? So we know that 1 AMU atomic mass unit is equal to 1.6 into 10 to the power of minus 24 grams. Mass of neutron in grams. Mass of neutron in grams 1.675 into 10 to the power of minus 24 grams. So we want the mass of the neutrons in AMU. Mass of the neutron in AMU 1.675 into 10 to the power of minus 24 grams upon the 1.6 into 10 to the power of minus 24 grams. You will get the answer in AMU. Approximately value is 1.008 AMU, atomic mass unit. So that's why relatively we are taking the mass is 1, we are taking proton mass is 1.007 AMU, electron mass is 000548 AMU. So electron having the smallest mass, that's why it is E by M ratio is more. Here you can see that it is what about the E by M ratio of the neutron. So neutron doesn't have the any charge but mass is 1. If you take the AMU, so anything is 0 by something you will get the 0. So it doesn't show the any value of E by M ratio, it doesn't have. So due to its neutral nature, so due to it doesn't have the any charge, due to its neutrality behavior, it does not deflected in the electrical field. If you pass the neutron in the electrical field and magnetic field, you cannot observe any type of the deviation, you cannot observe. Why? Because it doesn't have the any charge, it doesn't have. See the one JEE sample problem. In 0860 proton is doubled, mass of the neutron is 1 by 4th mass of electron remain constant. Calculate the percentage change in the atomic mass. Then here you can observe that two type of cases is there. So first one is ideal case, that means original case, ideal case. So given element is oxygen O816. From this here 8 protons are present, 8 electrons are present, 8 neutrons are present. Okay, this is the ideal case. This is the original case. So what is the hypothetical case here? Hypothetical case, what the changes happened, mass of the proton is double, mass of the proton. So mass of the proton in hypothetical case, mass of the proton in hypothetical case, how much? It is 8 proton in AMU, this is also you can take AMU. So how much? Initially it is the 8 protons, but they double the proton mass, so it will become 16 AMU. 16 AMU. So mass of the proton is double. Next one, mass of the neutron is 1 by 4th mass of the electron. So in hypothetical case, mass of the neutron is equal. Before how much? Before it is the 1 by 4th of the electron. 1 by 4th of the electron in the sense 8 into 1 by 4, we will get that 2 AMU. Mass is 2 AMU. So calculate the percentage change in the atomic mass after the hypothetical case. After if you doubling the proton and the neutron mass is 1 by 4th mass of the electron, you will get the some mass. What is the change happened between the ideal cases and the hypothetical cases? Hypothetical mass is equal, hypothetical case, mass in hypothetical case, neutron plus proton. So neutron plus proton, neutron is 2, proton is 16, total 80 AMU. Total is, it is AMU. Now we have to calculate the percentage, whatever the percentage. So percentage change in, percentage change is equal ideal case minus hypothetical case upon the 16 into 100. So 18 minus 16 by 16 into 100. The approximately value is equal 12.5%. So changing value is 12.5%. Assuming that mass of carbon 612 is 150 units, then the under this assumption, what will be the mass of the O816? So 12 unit atomic mass. So element, unitary method, by using of the unitary method, carbon 12 atomic mass, for example, if it is 150 units, what will be the mass of the O16? So O16 mass is equal how much? So 16 into 150 upon the 12, you will get the 200 units you will get. Before going to the atomic models, now we will discuss about the small fundamental things. So first of all, you can see that isotopes, they have the same nuclear charge but different number of the neutrons. Nothing but, if you take the example, you can take carbon 612 and carbon 613. You can take. So here you can see the same number of the protons are present. Same number of the protons are present, different neutrons and having the same nuclear charge. Otherwise you can define another way also. The atoms of same element having the same atomic number but different mass number they are having. So if you see here, this carbon mass number is 12, this carbon mass number is 13, carbon mass number is 14. But what is the similarity? Atomic number is similar. You can write any of the definition. So these are having the same nuclear charge. This means same number of the electrons they are having. So they are showing the same chemical properties they will show. They will show the same chemical properties, but physical properties are different. And we are talking about the charge to mass ratio, nothing but specific charge. E by m ratio also different for different isotopes. Why? Because mass is different. So automatically charge to mass ratio value also will be there, different will be there. So next one is isobar. Isobar you can see here only the mass number is same, but here atoms of different elements, carbon and nitrogen are different atoms. So you can see that atoms of different element showing the same mass number but different atomic number. Nothing but different nuclear charge will be there. Number. So chemical properties also will be different. Why? Because nuclear charge will be different, proton will be different. Automatically chemical properties also will be different. You can take the example of argon and calcium, whose having the mass number is 40 and atomic number is 18. This atomic number is 20. So mass number is same of a different atoms of different element showing the same mass number but different atomic number. So such type of species we are calling it as a isobar. We are calling isotope, same difference of number of neutron minus number of the proton. So you can see that fluorine and sodium. So here if you see in these two atoms, same difference of number of neutrons and number of protons will be there. So difference of the neutron in the sense A minus Z we will do. Difference of the neutron in the sense, how will you calculate the neutron? A minus Z we will do. Number of proton in the sense minus Z. So you can write A minus 2Z. So the difference of A minus 2Z will be different. So now you can see here the fluorine having the mass number is 19. So number of the neutron we have to calculate A minus 2Z. So 19 you can calculate, you will get the 1. Here also you can see you get the 1. That means number of the neutrons minus proton difference will be like a similar. So such type of the atoms or species we are calling it as a isodiaphers we are calling. That isotone is nothing but these are the different atoms having the same number of the neutrons. Same number of neutron in the sense A minus Z value will be like same. So if you calculate it, number of neutrons here will be A minus Z. So this is the A, this is the Z. A minus Z, you will get number 2. Here also this is the A, this is the Z, you will get the number 2. So 2, 2. That means A minus Z having the same number of neutron. Here also you can see that same number of neutron. A minus Z, you will get the number of neutron is 12. Here also you will get the number of the neutron is 12 you will get. So the atoms of different element showing the one similar property, that is A minus Z value is similar. That means number of the neutron value is similar. So such type of the atom we are calling it as a isotones we are calling. The electrons, atoms you can take, ions you can take, molecule you can take. If they are showing the similarity in the number of the electrons, that is called as a, that type of is called isoelectronic species. Nothing but same number of electrons. So for example, you can take neon, CH4, O2 minus 2, N minus 3, C minus 4, F minus 1, Mg plus 2, Al plus 3. So these are having the, you can write Na plus also. These are having the same number of the electrons. If you count, they will get the same number of electrons. The number of the electrons will be like a 10 electrons will be there. So any species showing whether it is the ion, cation, anion or molecule showing the same number of the species, that we are calling it as a isoelectronic species we are calling. One isoster. So these are the molecules which are having the same number of the atoms and same number of the electrons. So here CO2 and 2O, they are having the 3 atoms, they are having same number of atoms. These are having the 3 number of the atoms are having. Here also they are having the 3 number of atoms. If you count the electrons, you will get the electrons number is equal 22 electrons here you will get. Here also you will get 22 electrons you will get. So same number. Similarity is number of atoms are similar, number of the electrons are similar. So if you see the OF2, you are seeing the OF2. So here also you can see that number of the atoms are 3. Number of the atoms are 3. One hydrogen, one chlorine and one oxygen is there here. So here you can see the number of the electrons total. So in the oxygen and 2 fluorine atoms are the 26 atoms are the 26 electron collectively. This molecule collectively collect 26 electrons. So here also you can see chlorine is a 17 and oxygen is a 8 and this one is added. So these are having the 26 electrons. So these are having the same number of the atoms and same number of the electrons are having. Those are called isoster. So next session we will discuss about the J.J. Thomson atomic model, alpha ray scattering experiment and Rutherford atomic model we will discuss. Along with that one we will discuss some sample problems of the NEET JEE we will discuss. So thank you for watching.